One small thing went wrong in one corner of it, the kind of small fault that happens all the time and is forgotten by noon. This time, by the end of the day, the whole of it was in crisis. When something that large goes wrong, you look for something large behind it. A crisis that size, you assume, must have had a cause to match, some single great failure behind it. So you go searching for the big cause a big crisis surely demands. Often there is none to find. So go back to where it started and measure the thing that set it off. It is small. It is the same ordinary kind of fault the system meets and shrugs off without a trace, week after week. Put its size beside the size of the crisis that followed, and the two do not match at all. Whatever turned that small fault into a crisis, it was not the size of the fault. To see what did turn it, build the thing in front of you. Picture the system as a handful of parts, each joined to the ones near it by lines along which trouble can pass. Off to the side, keep one quiet measure: how tightly those parts are joined, how freely something can move from one to the next. Then set off a single small fault in just one of them. Begin with the parts only loosely joined. Set off the fault and watch what it does. It reaches the one or two parts beside it, and there it stops. With little joining them, there is nowhere further for it to go. The system takes it in stride, the way it always has. A part or two deals with the trouble, the rest never know, and the small fault stays small. Loosely joined, a problem stays a problem. Now join the parts more tightly and set off the very same fault again. This time it does not stop at one or two. It passes along a line to a part it touches, and that part, in trouble itself now, passes it to the parts it touches. From a single starting point, a front begins to move outward, part by part, each one handing the trouble to the next, along the lines that join them. Keep the joining tight, and watch the front go. With so many open paths between the parts, the trouble finds a way onward at every step, and what began in one corner reaches further and faster across the whole. More of the parts are taken, not because the fault grew, but because the way was open for it to travel. The same small fault that died in a corner before is now moving through everything. Step back from the parts and watch one measure instead: how tightly the system is joined. Low, and the trouble dies in a corner. High, and the same trouble travels until it has reached the whole. The fault that started it was identical in both. The size of what followed was never set by the fault. It was set by how freely the system let the trouble move, the one thing the surface never showed. Now hold the two runs side by side. The fault is the same fault, set off in the same part. Only one thing differs between them: how tightly the system is joined. On the loosely joined side, the trouble touches a part beside it and dies, and the system carries on as though nothing happened. On the tightly joined side, that same small fault passes from part to part, the front running on along every open path, until no part is left untouched and the whole system is in crisis. Same fault, same starting point, and at the end, one system stands unharmed, while the other has come apart entirely. Nothing about the fault chose between those two endings. The joining did. The crisis was never in the trouble that started it. It was in how freely the system let that trouble move. And it is not chance that decides it. Run the tightly joined case again, from the same fault in the same part, and the trouble travels the same way and reaches the same end, every time. Watch it closely, and you can follow each step. This part hands it to that one to the next, each move caused by the move before it along a line you can point to. Nothing here is luck. The same system, joined the same way, meets the same small fault and comes to the same crisis, every time. Test it two ways. Swap that starting fault for any small fault the system meets all the time. Tightly joined, it carries any of them to the same crisis. The particular fault that set it off was never the cause. Now try to undo it. Cut one part loose after the trouble has passed through, and the crisis does not lift. What has been reached stays reached, and one part cut free saves nothing. To have held it in its corner, you would have had to keep the system loosely joined from the start. Pull the whole picture together. A handful of parts joined by lines, a single small fault set off in one of them, and, when the joining is tight enough, that fault passing from part to part along the open paths until it has reached them all. You have been watching one thing the whole time, a small trouble traveling through a system until a local fault has become everything. That traveling, from one part to the next until it has taken the whole, is what we will call a spread. It is no special trigger and no great cause, only an ordinary fault the joining let move. Hold the two ways of watching together. Watch only the fault, and you learn almost nothing. It is small and ordinary in the run that ends quietly, and small and ordinary in the run that ends in ruin, the same trouble either way. Watch how tightly the system is joined instead, and you can tell the two apart before the fault has moved an inch, one held loose and safe, the other wound tight and ready to carry anything that goes wrong straight through. The fault never tells you which it will be. The joining always does. Stay with the small fault at the moment it strikes. It looks like every harmless fault before it, no larger, nothing about it that says crisis. And that is the whole trap. The thing that set off a disaster looked no different from the 1,000 troubles the system had shrugged off. There was no great cause to find, because the size was never in the cause. Nothing here was chance, no rare shock, no stroke of bad luck struck from outside. The fault was ordinary, and the system carried it everywhere because of how tightly it was joined. The problem stayed small. The spread did not. Carry this back to where you began. A small fault in a system is no longer a thing to wave off as small. On its own it is nothing, but you no longer get to judge it on its own. Whether it stays small or grows into a crisis is not written in the fault at all, but in how tightly the thing around it is joined. So you stop sizing up the trouble, which tells you little, and start asking how freely the system will carry it. And the question quietly changes. Not, was that fault too much to bear, but how freely the system would carry whatever went wrong. You are not learning that everything stands one fault from ruin, or that all trouble runs wild once it starts. Most systems are joined loosely enough that a fault dies near where it began. And this is not a difference too small to see growing on its own. The fault is plain and ordinary. What you learn to read is how freely a system will carry an ordinary fault. Let the whole picture stand. The small ordinary fault, no different from 100 others. The parts and the lines that join them. The same fault dying in a corner when the joining is loose and carried to the whole when the joining is tight. And the front moving part to part along the open paths, turning a local trouble into a crisis no one watching the fault alone could have seen. Hold them together. The trouble was ordinary. What made it a crisis was how tightly the system was joined. A small fault becomes a crisis not by growing, but by how freely the system carries it. Yet sometimes nothing goes wrong at all, and still two systems that began almost exactly alike drift to endings worlds apart, the gap between them set by a difference far too small to have seen.